Alright, so you are welcome back to this amazing video. In today's class, we are going to discuss what we call projectile motion. So before we do that, let me list all the things we are going to cover in this video. So you pay maximum attention as I list them down. So things to cover, that's the first thing. Things to cover. Things to cover in this video. So the first one, we are going to discuss definition of projectile motion. Definition of projectile motion. Definition of projectile motion. And after that, we discuss the key features. Key features of projectile motion. Key features of projectile motion. Then after that, we are going to look at what we call the components of the initial velocity really, at the point of projection. What is this point? It is the point at which our time because of now 0. Okay? Now the fourth one, we discuss what we call acceleration. We discuss velocity. Okay? And we discuss displacement. Okay, at both x and y directions. Okay, at the point t, or at let's say at time t. Let's just go at time t. At time t after projection. At time t after projection. Then the fifth one, once we are done with this, we are going to discuss what we call the key equations. The key equations in projectile motion. Under these equations, the first one under this is what we call time taking. Time taking to reach the maximum height. Time taking to reach the maximum height. That's the first one. And thereafter we discuss time of flight. After time of flight, still under the word key equations in projectile motion. After time of flight, we are going to discuss maximum height attained. Maximum height attained. And after this maximum height attained, we discuss horizontal distance covered. And this horizontal distance covered is what we call the range. Are you with me? So we are going to discuss the range. Okay? Then after horizontal distance covered, we are going to look at what we call maximum range. Okay? Still under what now? Under the key equations, maximum range. Then after this, the sixth one, we now discuss what we call relationship between the maximum height and horizontal range. Then hereafter we will discuss ranges of complementary angles. Then after this, we will now discuss the last but not the least, I will call equation of trajectory. Equation of what now? Trajectory of a projectile. These are the things that we're going to discuss in this wonderful video. So please, I want you to stick around and watch the entire video from the beginning to the end so that you won't miss any part of this. So let us go without wasting time. The first one, definition of what now? Projectile motion. What I will do is I'll give you a simple definition of projectile motion. So we don't need to compound the issue now. Just simple one as we go ahead with the video. So the first one is what definition of what is projectile motion? Projectile motion is the motion experience. Is the motion experienced by an object under the influence of gravity. So underline the word gravity. Okay? Underline the word gravity. So the motion of the body under the influence of gravity is what we call projectile motion. So we can as well call projectile motion under gravity. Okay? Motion under gravity. So that's another name for what now? Projectile motion. We can call it motion under gravity. So this motion, okay, moves in a parabolic path. Parabolic path known as trajectory. So underline the word parabolic path, underline the word trajectory. So with this, we are going to go under the definition right now, projectile motion. So please, I want to clean this space. Pause the video and write all the things to cover down. So I want more space to work now, to work as we go along. So what's the second one? Key features of projectile motion. It is very important that you know all the things as far as the key features of projectile motion is concerned. So what are the key features? What are the key features of projectile motion? The first one is that a projectile motion is a two-dimensional motion. That's the first key. One is a what now? A two-dimensional motion. Motion. What's the meaning of this? We are calling it for 2D. Remember, this is what 2D. 2D means what now? Dimensional motion. What is the meaning of two-dimensional motion? It means it has what we call horizontal motion. Horizontal motion. Are you with me? In X direction. In X direction. And so have what we call vertical motion. Vertical motion in Y what direction. So at any point in time, a projectile must have two types of motion. The first one is what now? Horizontal motion, which is in the what now? X direction. And second one is what we call vertical motion, which is in the what now? The Y direction. The second key feature, okay? Most calculations under projectile, we neglect air resistance. Take note of that. We neglect what now? Air resistance under what now? Most calculations under projectile. So we say what now? Air resistance. Air resistance is negligible. Negligible. Okay? Air resistance is what now? Is negligible. And the only force that affects projectile motion or projectile as a body is what we call force of gravity. So force of what now? Of gravity. That is the only force that affects what now? The projectile. Since we have what now? Neglected what now? Air resistance. So please take note of this word now. The key features of what? Projectile motion. So we are going to use them to solve questions, and they are very important. So this one is gone. Video is gone. Key feature is gone. The next one is what we call components of the initial velocity at the point of projection. So now look at it. This is where the work starts. So pause the video and write all these ones down because I want to write them up. So permission to write them up. So I'm going to write them up. Now let's go. Write this one up. Write this one up. So I have more room to put. Yeah, so how I will invite them. Alright, so now Now look at this. The next one that we want to discuss is self-application motion. Don't forget this. Now, they will go down projectile motion. Okay. So the next one is what now? Components. Components of the initial velocity. Initial velocity at the point of projection. Point of projection. And what is this point? As if the point where our t is equal to what now? 0. Now let us consider a projectile which is thrown into air from point A to point B as shown in this one now diagram. So we have this, please pay attention. Let's say the business now. We have this. Next week. These are what now? Our y-axis. These are what now? Our x-axis. At this point, we have 0, what now? 0. What is projected into here with an initial velocity what now? U, which is the initial velocity. So when we go like this, and come back to this. So call it what now? We need point A to this point what now? B. Ground to ground motion. Are you with me? Ground to ground motion. From this point A to this point what now? To this point B. Now, the body will have two components of initial velocity that we call the horizontal component and the vertical component. So we have our horizontal component in this direction, u of x. We have our vertical component in this direction, called what now? U of y. Then in this case, the initial velocity will have an angle of projection. That angle is the angle that it makes it work now, the horizontal. So we call this what now? So like I told you, this body will be going like this. As the body is going, at any point it has two what now? Two motions occurring. The first one is what now? Vertical motion, and the second one is what now? Horizontal what now? At any point. So at this point, the body will have what now? Vertical motion. Horizontal what now? Motion. Here, we have what now? Our u. So here, we have our uy, we have our what now? Our ux. At this point, the body will have what we call u of x. Our u of y is what now? 0. Let me explain. As the body is going upward, the velocity will be what now? Will be decreasing. Vertical component of the velocity will be decreasing, to be decreasing, to be decreasing. Until this body gets to a point, okay, whereby the vertical component of the velocity because what now is 0. This point is what we call the maximum height. So which implies a projectile will have a 0 velocity at maximum height. And again, a projectile will have only horizontal component of its velocity at maximum height. So I label this case H mass. H mass. Are you with me? This phase 2. This phase 2. But you have what? Vertical component. Horizontal what now? Component. And you have our what now? Our u here. So our vertical here. We have our what now? Our u of what? Our u of y. So at any point, it must have what now? Two what now? Two motions. Both vertical and what? And horizontal. But at this point, it has only what now? The u of x, which is the what? Horizontal component of the velocity. So let's bring this structure out. Okay? At point t equals to 0. At point t equals to 0, this is what now? Point of projection. We must resolve this one into components. Okay? Expression of this initial velocity will start at point t equals to what now? 0. So let us bring this shape out. We have this. We have this. Okay. We have our what here? Our u. U stand like this. We have our what here? U of y standing like this. We have our what now? U of x standing like this. And mind you, from here to here is what we call the horizontal distance curve, which is what now? The range. Okay? From here to here is our range. Alright? So here we have our work now theta. Let me mark this. If I should bring this structure down like this, parallel lines are equal. So this one is v of y. We also have our work here, our u of y. So this one comes what we call a rectangle triangle. So we want to know the what now? The us component and uy component of this what now? U, and this is the initial work now. From trigonometry, we can use what we call our SOHCAHTUA. Okay, so let's go for the first one. Ka means what now? Cosine equals to what? Adjacent all over hypotenuse. So we have cos theta equals to what's our adjacent? That's what now? U of x. We have u of x all over. What's our hypotenuse? That's our what? Our u. So which imply when you cross imply, we have our what now? Our u of x will equals to what now? U cos theta, because it's equation 1. Equation 1. Equation 1. U of x at point of projection when t equals to 0 is equals to what now? U cos what now? Theta. And u of x is what we call horizontal component of the initial velocity at time t equals to 0. I repeat, u of x is called what now? Horizontal component of the initial velocity at time t equals to what now? 0. So let's do the next one. Similarly, I can have something like this. Our sin theta will be equals to u of y. What is sine? Sine is equals to what now? Opposite over what now? Hypotenuse. Where is the opposite? U of y. Where is the hypotenuse? U. So I have u of y all over u. When we cross multiply, we have our u of y to be equals to what now? U sine theta. All this equation 1 now, equation 2. So let's define. What you say u of x is? U of x is what we call the what? Horizontal component. Horizontal component of the initial velocity. At time t equals to what? So which is what? Point of what now? Projection. Then what's our u of y? U of y is what now? Vertical component. Vertical component of the what? Of the initial velocity. At time t equals to what now? 0. Then what is this theta? Theta is the angle that the what now? Resultant makes with what now? The horizontal axis. This is the resultant. Or use the resultant. So let's try this one out. Remember, we have to find the resultant at point t equals to 0. See what we're going to do. This thing now is what now? A rectangle triangle. Are you with me? So this is once I have side, this is one side, this is another side, this is another side. So when the question involves sides of a right angle triangle, I can use Pythagoras theorem. So our u here, So let me see. Okay. So let's go to this page. So I can say our u using Pythagoras theorem. Hypotenuse squared equals to opposite square plus adjacent square. So where the hypotenuse, our hypotenuse is what? Is u, is equals to what now? All squared. Where is the opposite? Our u of x all squared. Then plus, where is the adjacent? U of y all what? All squared. So we have what now? The hypotenuse square, which is what now? Hypotenuse square equals to what? Opposite square plus what now? From adjacent square. Where is our what now? Our hypotenuse is our u. So write our u out. Where is opposite? Opposite is what now? U of what now? Y all squared plus. Where is adjacent? We have our what now? Our u of x all squared. We can write this in any direction. Our u of x can come forward. Our u of y can go to the back. Anyhow, because addition is commutative in mathematics. What do you mean by commutative property? Where you get the word commutative, okay? Commutative property. It means when I interchange the combining position of the combining element, I'm going to have the same result. 3 plus 2 is the same as what now? 2 plus what now? So this one now, I can put u of x forward and put u of y backward. It will not have any effect. So this one is correct. So what are you? Are you going to have the root of u of y all squared plus u of x all squared? Put this one to what now in bracket. Because it is what now. Then this is what we call the resultant velocity. Okay, at time t equals to what now? 0. Okay, resultant velocity at time t equals to what now? 0. And what's time t equals to 0? At the point of what? I'm adding on the at the point of projection. Okay, when at the point of projection, our t equals to what now? 0. So what is this now? So where use what? Our use what we call the what now? Or resultant velocity. Resultant velocity. Okay, at time t because of what now? So we have 3 equations now. The first one, u of x. Second one, u of y. Third one, our what now? Our u. So let us get the what now? The angle which this u makes the what now? Horizontal. Okay? When you are studying question under what now? Don't be tempted. So question will give you what now? This angle here. Change it back to what now? To horizontal. Are you with me? That angle that this thing must make reach what now? The horizontal what? As it's mind you, they give you this one to be 30. It means that angle because what now? 60. Because everything here is what now? 90. Are you with me? So let's write this thing up. Since you have the diagram too, let's write this one up. Let's write this one up. Let's write this thing up. So let's go. Let's go from that shape to from this shape out opposite adjacent. Which shape is that? Tua. That is time. What's the what now? Adjacent. So we have our tan theta. Tan theta is equals to opposite is what now? U of y all over u of x. So theta only we add tan or tan inverse of what? U of y all over u of x. Put this one to what now in bracket and call this equation what now in 4. So we have equation 4. What is theta? Theta is the angle. Is the angle that the resultant velocity, which is our u, okay, makes with the horizontal. This is what now? Horizontal. I mean the positive what now? X axis. Positive axis. Are you with me? Positive. So we have 4 equations here. Now, class, you can now ask us to write this thing in what now? In vector form. Because questions can come out in vector form. So how do you write this thing in vector form? This shape here. So vector notation. In vector notation, my u to become a vector will be equals to u of xi plus u of yj in vector form. This is the what now? The resultant. Are you with me? In vector form. So put this one to what now? In block form and put equation what now? So we have 5 solid what now? Formulas under the first part. The first one is that component. Second one, partial component. Third one, we have our resultant. The fourth one, we have the angle, and the fifth one, we have our what now? Our resultant in our resultant is what in vector form or vector notation. So let's move to the second one. And the second one is what we call what now? The acceleration, velocity, and displacement in x and y direction at any time t after projection. All the things that I've discussed here, they are the things that occur at the point of projection. Meaning, at the point where our t equals to what is 0. So where are we now? We want to see what will happen after time t, maybe after 1 second, after 2 seconds, after 3 seconds. What will happen? Okay, now see. Let's go to the second part. Let's go to the second part. Pause the video and just write all these formula down. We are seeing some questions based on this formula. Are you with me? So let's go. Let me take my time to wipe this thing off. Take my time to wipe this thing off. Take my time to wipe this thing off. Alright, so okay, let's wipe this thing off. Take my time to wipe this thing off. Take my time to wipe this thing off. Take my time to wipe this thing off. Okay, so to wipe everything off. So now, before we go to the next one, I want us to take these key notes down. Okay, if you see the diagram that we have, what is diagram? Okay, what is diagram? We have this space, we call it our work now, U of X. And we say our U of X is what is 0. And this is we call it work to the maximum work height. We always ask question, okay? We ask question that what is the speed or the velocity of a projectile at its maximum height? The speed or the velocity of a projectile at its maximum height is what now? The horizontal component of the word now, velocity. Are you with me? Is that component of what? Of velocity. So the speed or velocity of a projectile. We always ask question like this: projectile at its maximum height. Maximum height is the horizontal what? Horizontal component of the initial velocity. The component of the initial velocity. This what? U of what? U of X. Okay? Now U of X what now? U what? U of theta. And take it again. Take note. This U of S is constant throughout the entire motion of a projectile. Note again, U of S is what now? Is constant. It's constant throughout the entire motion. But our U of Y will change based on time. Okay? U of Y changes based on time. It means U of S is not time function. It's not time dependent. Okay? Anytime you should bring, U of S will remain the same. It doesn't rely on time. But our V, U of Y, will rely on what now? On time. As time changes, our U of Y also will change with time. So next one now, which is what is called acceleration. Acceleration is called velocity. It's called velocity. And the space length and the space length. Okay, in what? In X and Y directions. In X and Y direction at time t after projection. Okay? After projection. So here now we have time t. There is time here. And the first one no time. And let's go. Once you have time t, we must have both directions, X and Y direction. The first one, let us take the acceleration. So what happened? Acceleration first. Acceleration, take note. Since our U of X is constant, when you have constant velocity, acceleration will be equal to 0. Are you with me? When you have constant velocity, acceleration will be equal to 0. So it implies in X direction of the motion, our A of X is equal to 0. Are you with me? Our A of X is equal to meaning X direction of what now? Acceleration equals to what? 0. Why? Because our U of X is constant. When velocity is constant, we have what? Our A to be equal to what? 0. What about the Y direction? You know, we said we are going to have more than 2 directions, both X and Y. What about the Y direction? Our A of Y is equal to what now? Plus or minus what now? G. Our A of Y is also what? Plus or minus G. If it's plus G, if the body is what now? Drop from the height, it's coming down, it's moving with gravity. Are you with me? And it's what now? Minus G. If the body is what now? Thrown or what? Mean the body is moving against gravity. Another force is what that pushes the body down to the earth. Are you with me? So it means what now? That's what now? Downward now direction. If you now throw an object up, it means that object is moving what now? Against gravity. In that case, our d will be what now? Negative. But if that object is dropped from the height like this, our d will be what now? Positive. So next one, velocity. Velocity. Let's call velocity. So we are going to what now? Acceleration at what? Time t after projection. Velocity at what now? At time t after what now? After projection. So let us go. Now, you recall that we have equations of motion. That is equation of what now? Uniformly accelerated what now? Bodies. Okay? Let us write the equations here. Let us write the equations here. So we have the first one saying that what? Our v is equals to what? U plus at. Okay, so our v squared equals to what? U squared plus 2al. And our x equals to what now? Ut plus rat squared. And the last one, x equals to what now? U plus v all over 2 at the top now t. These are what now? Equations. Equations of motion. As uniformly accelerated what now? Body. Uniformly accelerated body. Okay? These are what equations. Okay? But for what? Projectile. This one will not be there. But there's no A here. You see? For projectile, we need to think something about what? This, and this on the projectile. So let's go for the first one. If I take my V equals what now? U plus what now? At. I want to know the velocity at what now? At x direction. So for x direction, this one will become what now? V of x. Excuse me. Is equals to what now? U of x plus A of x and what now? And t. U of x direction. A of x direction. B of x direction. So what happened to this? Our A of x is equal to what now? 0. So this one becomes U of x and what now? 0, sorry, plus 0 times what now? Times t. You with me? What's 0 times t? 0. So this our what? Our B of x is equal to what now? U of, which equals to what now? U plus what now? So it means the value of the velocity after time t of projection is u cos theta, which is constant. We said it before, and we've shown that is what now is. So our v of x is equals to what now? U of x after time t, which is just what now? U. What about the vertical what now? Vertical direction. Let's see what we're in the vertical direction. But in the two, simple vertical direction. So let's take y direction, which is the vertical direction. So we have our b, as is our b equals to what now? U plus what now? At. Okay, so we have our b of y equals to u of y plus a of y what now? T. Okay? And I said if that body is moving against gravity, you project the body upward. The body is moving what now? Against gravity. So in that case, our A of y will equals to what now? Negative g. Okay? Take negative value. So this should not become our B of y equals to u of y minus gt. Okay? So what is this? B of y equals to what are u of y? U sin theta. So now u sin theta. Put this in what now? Block 4. Put this one in what now? In block 4. All these formulas in block 4 are very important. We are going to use them more. Are you with me? So, a B of y other than t is u sin theta gt. But our B of y at time t equals to 0 is just what now? U sin theta. You see it? So our u of x at t equals to 0 is still what now? U cos theta. Does not change. Are you with me? So please let me write it down. Write it down. Let's continue. Continue. Alright, so here too. we can be asked to find the velocity with which the body will strike the ground. These are u of x. These are what now? U of y. What's now the velocity with which the body will strike the ground? Which is same as in what now? A. Another component of the velocity. So we have it like this. We have it like this. Okay, let me move this up. Let me move this up. Let me move this up. So we have our what now? Our b squared equals to what now? B of x all squared plus b of y all squared. So b equals to what? The root of b of x all squared plus b of y all squared. Mind you, b of x is this, okay? And b of y is what is this. So this is the speed of the velocity with which the body will hit the ground. Are you with me? So where b is what? B is the speed with which the body hits the ground. What is what now? B. And what? I can equally write something what now in vector form. Okay? Or because what now? Landing velocity. Are you with me? Or landing velocity. The velocity with which the body will strike the ground. Or landing velocity. Landing what? Landing what? Velocity. Same thing. Is there? Or landing what now? Velocity. Let us write something what now in vector form. Let's write it in vector form. So what will it be in vector form? Very easy. Our B, vector form, or vector notation. For this part now, we have our V equals to what now? V of x I plus V of y g. So this will give us what now? What are V of x? We still have U of x. So we have what now? U cos theta I plus what about what now? Our V of y. How do we work now? U sin theta and our d what now? Dt and what g. This is g is the what now in vector form. Okay? That is that about the second work now. Part. How we are using all these formulas now? We're going to solve questions using the formula. Okay? So this is a very important. This is what now? Velocity after time t of projection. Vertical velocity after time t of what now? Projection. Vy is the vertical velocity after time t of what? Of projection. And Bs is the horizontal velocity after time t of projection. So let us do the third one. What's the third one? What is what now? Displacement. Let's talk about what now? Displacement. Displacement after time t of projection. We discuss acceleration. We discuss what now? Velocity. Then let us discuss what now? Displacement. Displacement after time t of projection. After time t of projection. So we have, all right. So now for displacement now. The third one, which is what? Displacement. Displacement after time t of projection. Are you with me? So what is the one we need to use? We use this for displacement. Are you with me? We use this for displacement. So we have our x to be equals to what? Ut plus half at squared. Let's take what now? Y direction. Let's take the y direction. For the y direction, we have this one becomes what now? X. That's direction. Rather, taking this direction. X equals to UST plus half AST squared. What's our AX? 0. So here we have our x equals to UST plus half times 0 times 0. Which is equals to 0. So this is our x, which is the displacement in the x direction after time t of projection. It's equals to what now? US of what of t. And recall, our u of x is what now? U cos theta. So this one becomes u cos theta and what now? T. So these are what now? Our x equals to what? Ut cos theta. I've just kind of the what the formula. I've just count. Just put them in brackets. Then you put the what now? the number, right? Is what kind of what of the formula. So that's why I'm just putting in what in bracket. So how do T? So you also find what now? The displacement after time T of projection. I'm making one of time T, maybe 1 second, 2 seconds, 3 seconds. Well, because what now? UT cos what? Cos theta in the x what now dimension. Let's go to the next one. Let's go to the next one, which is what now? Vertical direction is y what? Y direction. So we have to see what now? U of x equals what now? UT plus half AT squared. This one we don't know what now? Y equals to what now? UYT plus half AYT squared. Now, in this case, our y is what now? Is upward, going upward. So this our g goes to what now? Minus this one here. A of y goes to what now? Negative g. So we have y is equals to what now? U of yt minus half gt. So what's our u of y? U sin theta. So our y is equals to what now? U sin theta times t minus half gt. So our y will now goes to plus ut sin theta minus half gt squared. So where s is displacement. Displacement after time t of projection. Okay. Then what about y is displacement. You can say it here, you can say distance. Okay. Displacement after time t of what? Of projection. If you ask us to calculate what now? Magnitude of what now? The displacement after time t of projection. What are you going to do? The same thing. Use what now? Pythagoras what now? T of, so it means our displacement. Magnitude of displacement. Magnitude of displacement. After time t of projection, B, our D. Magnitude, are you with me? Is equal to what now? The root of our s all squared is what now? Y all squared. This is another formula. Under what? Projectile. Are you with me? Can we continue class? So, we're taking many formulas now. Just see. The formula to use to solve a particular question will depend on the parameters that you have in the question. Okay? If you say talk about what now? The vertical displacement after time t of projection. That is this formula. When I say what now? The horizontal displacement after time t of projection. That is this formula. Get me? So it's very easy. And that's what what magnitude. Use this one now. Use this. We just become. This is one question. Plenty questions. Let me just give us all the formulas. Then I'll now summarize them. I'll list them out. Also, question. So what is the next one on the agenda? Now, what we call what? The key equations in projectile motion. This is where we are going. Key equations. You can pause the video and write what now? The formulas down. I'm going to wipe the board off now. So you can pause the video and wipe it. And what? Write the formulas down. Okay? So, clean. So now please don't forget to subscribe. Okay? Subscribe to our YouTube channel and make sure you pass on the links to your friends. Writing JUPEB, JAMB, A-level, JUPEB. This video help us to make this video to go viral because everybody writing JUPEB needs this video. Are you with me? All the candidates writing JAMB, they need it. Projectile motion has never been taught in school. Are you with me? Projectile motion has never been taught in school. So everybody needs this video. JUPEB students, JAMB students, JUPEB students, and if you need physical class, I'm going to drop a link, a WhatsApp link under this video. Are you with me now? Click the link to join the group, then ask any questions you want to ask. Like this video, Comment below so that we have what now? Engagement. So the more engagement that we have under this video, the more YouTube will want now will show this video to other students that need this video. Everybody must watch this video. Are you with me? Web student must watch, JAMB student must watch, right student must watch. A-level students, you are not left out. Subscribe to our YouTube channel. Pass on the word now. The beautiful message. Spread it across. Spread it across. Are you with me now? You want to join our physical class? Join our word now. Click the link below this video. Join the group and ask your question. If you want to join physical class, you can join us. Online class, you can join us. For any lectures, JUPEB, JAMB, JUPEB, A-level classes. God bless you. Let us continue with the. So the next is what now? Keyword now, key equations. Now pay maximum attention. Please pay maximum attention. Keyword, key equations. Key equations. Keywords in projectile motion. And the first one I will say is what now? Time taken to reach the maximum height. Time taken to reach what now? Maximum what? Maximum height. So let me recall. Equation of projectile. Okay, like when we have it there, we have our u to be equal to what now? B under u plus 8, don't forget. We have our what now? B squared equals to what? U squared plus 2ax. I'm going to be using this now. We have our what? S equals to what now? Ut plus half at squared. If I were you, all the formulas that I've done, just summarize them, write them down. So that you can follow the video. If I'm about to solve what now, just write them down. One by one. Write them down. So let's go. Now, first one, say we have what we call time taking. Time taking by projectile to reach the maximum height. Time taking to reach maximum what now? Maximum height. So let me bring the shape back. Maximum height. Let me try and bring the shape back. Shape, come back. You have this, you have this, we have this. This space is our what now? Maximum height. This space, maximum height. You see? These are what now? These are what now? U of x. From here to here is our range. Is our range. From here to here is our range. These are what now? Our y. This and this is what our what now? U of y. Okay, so and this is our what now? Our what? Our initial velocity of what now? Of projection. So we have the diagram with that. Now I want to get the time to take this body from this space to this space. Time taking to reach the maximum height from this space to what? To this space. I will use the first word now. First equation of what? Of motion. Are you with me? So say the call. B equals what now? U plus AT. Because that is what now? Vertical direction. And what B of y equals to U of y plus A of yt. And what's our A of y? Minus g. So this one becomes what now? B of y equals to U of y minus gt. Are you with me? This is the time I'm looking for. What happened to this guy at maximum height? At maximum height, you can still collect. Our B of y equals what now? 0. We only have U of x at maximum height. I repeat, at maximum height, B of y is equal to what now? 0. The velocity of the body at maximum height is what now? 0. Are you? If I do this body up and the body goes up, when it gets to the maximum height, it will stop momentarily before coming down. You can't just go and come down. It will stop momentarily before coming down. So at that point, at maximum height, the final velocity of the body is equal to what now? So now right, at max height, at maximum height, our B of y equals to what now? So it becomes what? So it becomes what? 0 equals to what now? U of y minus what now? Gt. Now this one, come to this side, our what now? Gt is equals to what now? U of y. So divide both sides by g. Our t is equals to what? U y all over g. Put this in what now? In block form. Are you with me? which is block. So this is our T. U of y is the vertical component. So when you hear a body is projected vertically with a velocity of 20 meters per second, they are talking about what now? U of y, vertical what now? Velocity. Are you with me? So U of y is what now? Is vertical component of the what now? Of the initial velocity of projection. Then what's our what? Or U of y? Can see the correct? So our U of y is what now? U central is correct. Our U of s is what now? U plus what now? U plus s. So we need this one here. Are you with me? So let us change this one. I can have this equation from time. Are you with me? If it involves velocity, vertical velocity and what now? And our g and this is formula. But when it involves what now? Angle. This is what we have got. T equals what now? U of y is U sin theta. So we have U sin theta all over g. Take down this formula to put it in work in block. I can have this for time taken to reach the maximum height. I can also have this for time taken to reach the maximum height. So our time taken to reach the maximum height, which is small t, is equal to what? U of y over g or U sin theta all over 2g. What's the next one? Time of flight. Time of flight. Time of flight, capital T. Time of flight. Time of flight. Time of flight. Don't let your mind be disturbed. What is time of flight? Time taking from A to B, A to B, A to B, from ground to ground, ground to ground. So you can first say time of flight is total time spent by a projectile in air. Total time spent during the course of its motion is what we call now time of flight. What is time of flight? It doesn't really define. Just small definition. You're going to cram everything on your head. See the structure from year to year. You see? That's time of flight. That is time of flight is what now? Time of flight is the total time spent by a projectile in air or total time spent during the course of his work now, entire motion. From here to here is work now, entire work now. Motion, you mean? So you can use the two right now. So let us go for time of flight. No, time of flight is twice time taken to reach maximum height. Time of flight is what? Twice the time taken to reach the maximum. Mind you, that is because we are negating what now? Air resistance. If not, it's not possible. It's not possible. Can I say, I was spending from here to here T. I'm asking from here to here T. It's not possible. If not about that what now, the key feature, we are negating what now? Air resistance. That's why our time of flight is twice the time taken to reach maximum now. Are you see? So T is 2 times what now? T. So we go, our T equals to what our first small one there? 2u by all over what now? All over G. Take note of these. All these formulas, take note of them. I'll do some questions on them. So I leave them out. So let me just be writing them down. So I'll do some questions using them. So what's our time of flight? Our time of flight, our small t equals to what now? U y all over g or u sin theta all over g. That's our small t. And our big T equals to what now? 2u y all over what now? All over g or 2u sin theta all over what now? Because u of y is what now? U sin theta. You see it here? So you can also say our t here, time of flight, can also be given as what now? Based on this, we have 2 u sin theta all over what now? All over g. So here, we have this formula that we can apply for time of flight based on the question given. We also have this formula we can apply for time of flight. So we've done time taken to reach maximum height. We've done what now? Time of flight. Take note of these formulas, please. I repeat. Just take your time to write them down. So let's go. What is the next one? The next one is what we call what now? The maximum height attained. It's not easy. That's a difficult time. So, what's the maximum height attained? This is maximum height. I'm going to use H for maximum height, capital H. Are you with me? Now, Which of the formula I can use this second formula for maximum height? So let us go. For maximum height. For maximum height. So no time. Alright, so now maximum height attained. Maximum height attained. Maximum height attained. Maximum height attained. So this was h for that. Okay? So that formula. Using b squared equals what now? U squared plus 2ax. Maximum height, still talking about what now? Vertical what now? Plane, are you with me? So we have our u of y, all squared equals what now? U of y all squared plus 2a of y. Then this s change to what now? H, which is what now? Maximum height. Are you with me? Why did I use this? Because maximum height, that's one. Maximum height. How maximum height at this point? H max. So the one is going like this. Vertical plane. With me? So we have u of x here. We have our u of x, u of y. Our range is here. Our range is here. But again, our u of x and v of y is what is 0. Please don't forget to please do. How many on this thing? Okay? How many on this? Because they ask us on every year. And at this point, at maximum height, the only velocity there is what now? Projectile component of the what? Of the velocity. So let us go. So minus actually. So we have what? U of y plus squared equals to u of y plus squared minus 2gh. Okay? So what happened at maximum height? At max height, you see, remember, at max height, what happened? Our what? Our b of y because of what? Is 0. So now 0 is equals to what? U of y plus squared minus 2g of h. This one will come here to complexity. So we have 2gh because of what now? U of y plus squared 2. That is our what now? 2g. So we have our h equals to what now? U of y plus squared all over 2g. So our h max is equal to what now? So h max, let me write it down here. H max equals to what now? Formula u by plus squared over to g. Kind of like that equal to reach the maximum height. Then h what now? H max, which is the maximum height attained by the projectile. Let's go. Next one. Remember, our u of y is what now? U sin theta. So this one becomes, I call that as this. U sin theta all squared all over 2g. Can be like this. I open this bracket, our u squared sin squared theta all over 2g. I can use any of these three formulas to go to what now? The maximum height attained. So our maximum height equals to h u squared sin squared theta all over what? 2g, or u sin theta all squared all over 2g. All these formulas in log form, they are very important. Very important. So what is that? Then the last one, under this is what we call the maximum what now? The range. This is what? Horizontal distance covered. So if you see a question that says calculate the horizontal distance covered, they are talking about the range. Okay? Range is the what? Is the horizontal distance covered. Horizontal distance covered. By a projectile. Good. Now, this range is mathematically defined as the product of the horizontal component of the initial velocity and the time of flight. So range R equals to what now? The product u of x times time of what now? Flight. Don't forget. Range is equals to what now? The product of the horizontal component of the initial velocity and what now? Time of what? Of flight. So here put it in log form. This is one formula for range. If I now explain this further, I have range. What are u of x? I have u of x times what are time of flight? 2u y over g. So I have 2u y over g. So when I combine this one together, our range is equal to what? 2 us u y all over g. So here I have this formula for range. Okay, what is t? T is 2uy. This is y. This is y. 2uy all over what? All over g. So these two can come for I have us u all over g. Okay, are you with me? Is it clear? So as is formula for range. If angle is now involved, what will happen? Are you with me? If angle is involved, so I'll have this. Being 2, what are u of x? U cos theta. So we have times u cos theta times what are u of y? U sin theta. So I have u sin theta all over what? All over g. So when I compare u times u squared. What means u squared times 2 sin theta cos theta all over g. Sine times cos, sine cos. 2 is here, 2 is here. U times u squared. Now, see one interesting thing. This is very interesting. Very, very interesting. Are you with me? Now, from trigonometry, under what we call addition formula. See the formula. Let me someone say, whenever I have sine A plus B, my answer will be equal to what now? Sine A plus B plus cos A sine B. Okay? A plus B, two angles. But if my A is now equal to B, what do you think will happen? I have having sine A plus A. Now because what now? Sine A cos A. Shall B will change to what now? A. Then plus cos A sine what now? Sine A. Cos A sine A. Cos A sine A. I'm having two of these, sine A cos A, sine A cos A, two of these. So you can say A plus A is what now? 2A. So this sine 2A give us what now? 2 sine A cos what now? Cos A. Okay? So which is why we have 2 sine theta cos theta. What will it give us? So this one is now, give us right now what? 2 sine theta. Okay? Cos theta. What will it give us? It give us what now? Sine what? 2 theta. So 2 sine theta cos theta equals to what now? Sine what now? 2 what? 2 theta. That is where the formula comes from. So this our what? Our range. Our range is also equals to what now? U squared sine 2 theta all over what? All over g. Okay? So that's where the formula comes from. Okay? So sine theta double angle 2 sine theta so 2 sine theta is the next one. Sine 2 theta. So let's now look for the range. Maximum. Maximum range. So our R is maximum. Mass B, so mass calculate mass B. R mass occurs when angle of projection equals to 45 degrees. Take note of that. R mass, maximum range occurs as theta equals to what now? 45 degrees. Write it down. Maximum range occurs when angle of projection is equals to what now? 45 degrees. Okay? So, as is that? So, which implies if theta is 45, we have been R equals to what? U squared sine 2 theta over G. For R mass now, what will happen? We now have what? U squared sine 2 times 45 degrees all over what now? All over G. Sin 45 is what? Times 2. That gives us what now? 90. So here we're having our R mass, see our R mass equals to what now? U squared sine 90 degrees all over what now? All over G. Sine 90 is 1. So which is why our R mass will be equals to what now? U squared all over G. This is the formula for what now? Maximum range. Maximum range. Formula for maximum range is what now? U squared over G. What about the formula for range? 2 US U over G or U squared sine 2 over G. For maximum range, we have U squared all over what? All over G. So that is all the key equations under projectile motion. So the next one is what we call relationship between maximum height and range. Between maximum height and range. Between maximum height. So just pause the video, write the formulas down, then allow me to clean this board. Okay? I'm going to clean the board. Clean the board from that side, from this side. Alright, so the next one is what we do. Relationship between maximum height and horizontal range. This thing is very special. Okay, because what now? Special case under what now? Projectile. Very special. So we recall that our what now? That our maximum height is equal to what? Use y squared all over what? All over G. And our range still recall. Our range is what now? 2US uy all over what now? All over G. If I divide h by r, I have h all over r. Let me divide them. It will be equal to what? U of y all squared all over G divided by 2u of x, u of y all over G. Okay? So this one will change to what now? Multiplication. We have u of y all squared all over G times, this is what? 2G, 9G, this is 2G, this is 2G, not 9G. For our height, it's 2G. So I have 2G here. It can what now? G all over 2ux, u what now? U_y. What is happening in class? I have h over r here, h over r. So our G, we cancel out what now? G. Are you with me? So what happened? 1us, we cancel what now? 1uy, rather, cancel what now? 1uy here. We left what now? Ordinary uy. This is uy times uy. Okay? I have uy down here. So 1uy we cancel what now? 1uy. So this is where it becomes h over r is equals to, I have ordinary uy left here all over 2 times 2, I have 4. Then I have what? The ordinary us left here. Okay? So what's the next thing? 4 come here and go here. I will cross multiply. Are you with me? So now we are having 4h. As 4 times h, 4h, then equals to what now? RUX all over RUY all over US. Put this in block. This is one of the formula, okay? One of the formulas and next word now. H mass with horizontal range. But we know that, we can't stop here. Our U of Y is U sin theta. And our U of X is what? U cos theta. So this implies I'll still go ahead and have 4H is equals to 4H is equals to and what is this? U sin theta all over U cos what now? Theta. And under trigonometry, we recall that what now? Our tan theta. nothing, our tan theta is equal to what now? Sine of theta all over cos of what now? So which guy center of theta here become what now? Tan what now? And because our u here becomes what now? U here. So our what now? Our 4h is now equal to what now? R what? Tan theta. Take note of this formula. This is what now? Relation between what? The maximum what? Height and the horizontal what now? Range or the horizontal distance covered. So where what? Where h is maximum height. Maximum height. Maximum height. Then our r is what now? R is what now? Range. Range or horizontal what? Distance. I think you know that. Horizontal what? Distance. Horizontal distance. Horizontal what now? Distance. Okay? So this formula is very important. This formula very important. So this is just what now? Relationship between maximum height and range. That's the special formula. I connect what our maximum height to what? And range together. That's the special formula. Then 4h equals to out and what now? Out. So what's the next one? The next one is what now? Ranges of complementary angles. Ranges of complementary angles. I don't want this video to be too long, so I want to have two parts of this video. This one is just for what? For this one. Then the next one will be for what now? For general question what now? Solving. Okay, so make sure you watch the video. I'll put the link of the second video down this video. Subscribe. Are you with me? Comment. Like this video. The more you like this video, the more it will work now. We will take it out to others so that they'll be able to watch. We need people to watch this video. Are you with me? Another projector. JAMB student to watch. JUPEB student can watch. My student can watch. A-level student can also watch. Okay, so you must subscribe. Comment in the comment section below, and I'll drop our WhatsApp link. Don't forget, you can join the WhatsApp link under this video. Okay, for physical class, contact us. For online classes, contact us under JUPEB, under JAMB, under JUPEB, under A-level, and share the link to all your friends. Once you see this video, spread it out, send to your friend. Don't just hide it. Good things, don't hide them. Okay, help others too. Don't be the only person that will pass. Spread the link out. Make sure you subscribe. What are you still looking for? Have you subscribed? God bless you. So let's continue. Let's continue. So we have ranges of complementary angles. Complementary what? Angles. What are complementary angles? That's the first thing I have to know. Complementary angles are angles that add up to give 90 degrees. So angles that add up or sum up to 90 degrees. We call them what now? Complementary angles. So here, it has what's the complement of 30 degrees? That's what now? 60. Because 30 plus 60 will give us what now? 90. What's the complement of 20 degrees? That's what now? 70 degrees. What's the complement of 35 degrees? That's what now? 50 what? 55 what? All these angles are what now? Examples of complementary angles. So what happened to them? What happened to rates of complementary angles? They will ask us to form of ratio. Okay? In form of ratio. So let us go. Let us go. So we have this. Now recall that range is equal to what now? U squared sine 2 theta all over what now? All over G. See correct? For range. So let us assume we want to use 30 as case study and 60 just as example. Before I give you the facts under range of complementary angles. So suppose I'm using 30 and 60 as case study. So what is the range of 30? That will be what? U squared sine 2 bracket what now? 30 degrees all over G. This is not because of what now? U squared Sin what now? 60 all over what? All over G. Are you with me? So let's go to what now? Range of what now? Angle 60. Range of angle 60 will be equals to U squared sine 2 bracket what? 60 degrees all over what now? All over G. So what do I have here? We have U squared sine 120 degrees all over what? All over G. So this is range of what? Of angle 60. And 30 and 60 they are what now? Complement what now? Angles. Are you with me? Now, when you punch your calculator, sin 60 and sin 120 are the same thing. Okay? Sin 60 is what now? Root 3 over 2. Sin 60 is root 3 over what now? Over 2. And sin 120 is root 3 over what now? Over 2. So what can you say about this? It means what now? Complementary angles, they have the same range. Complementary angles have the same what now? So if I say, okay, if this one is theta, what will be this? 90 minus what now? Theta. This one is theta. So this one is what now? 90 minus 30, which is what now? 60. So it means R of theta is equals to R of 90 minus theta. What's the meaning of this? Complementary angles. Complementary angles have the same range. Same what? The same range. And the last according to what? Their ratio. Their ratio is what now? 1 to 1. 1 to 1. This is 1 to 1. Because if I have this, R theta all over R 90 is 2. Because you work now. 1 over 1. So the ratio of complementary angles is what now? 1 to 1. Take note of that. Ratio of the range of complementary angles is what now? 1 to 1. The ratio of the range of complementary angles is what? 1 to 1. I repeat. The ratio of the ranges of complementary angles is 1 to 1. Ratio 1 to 1. Ratio 1 to 1. What's that? The last one is what we call equation of trajectory. Equation of what now? Now pause the video, write the formulas down. Let's go to the equation of what now? Trajectory. Equation of what now? Trajectory of the projectile. That's the last one. Before we solve what now? Questions. So the equation of trajectory. Equation of trajectory. Okay, of a projectile. Projectile. Now, we recall that we have what now? Displacement in vertical direction, and we have displacement in what now? Horizontal direction. So the formula we have is what? Our x is what? Displacement in horizontal direction is equal to what now? Ut cos theta. You can see call this. Then that of y is equal to what now? Ut sin theta minus RD squared. These are the what now? Displacement in x and y direction respectively. So if I want to solve equation of trajectory, I must use these two what now? Displacement. Are you with me? What's the next thing? I must find a way to eliminate what now? T. I must find a way to eliminate what now? T. So suppose I call this equation 1. This one equation 1, 2. So from equation 1, our T, look at this. I have x what now? Ut cos theta. So I want to eliminate what now? T. I will say all over, make this over a formula. All over u cos theta. All over u cos theta. I want to make T over a formula, making T to stand alone. So I will divide this by what now? U cos theta. So this one here, cancel this and this. So if this ordinary T will be equals to what now? X all over u cos theta. Let's call this equation what now? We now say put or substitute. Put T equals to what now? S all over u cos theta in equation 2. Okay? I got this T from equation 1. Are you with me? So put this thing back into equation 1 to what we call simultaneous equation. So put it back. What's equation 2? You say y is equals to what? Ut minus ut sin theta, ut sin theta first minus what? Half t squared. So anywhere we see t, we put x all over what now? U cos theta. So this one becomes y is equals to what now? U dot s all over u cos theta dot sin what? Theta. Do you understand that? U t is this. Okay, this is what I put here. S over what? Then times sin theta. Dot this one now times u. Then minus what now? Half d. What about t? We have x all over u cos theta. But for this one, it is now what now? It is square. It is square. So what's the next thing? We have our y to equals to. Can anything go here? Yes. U can cancel what now? U. Now we are having x sin theta all over cos theta. Then the result now. Half d. Open this bracket. Half s squared all over u squared sin u squared cos squared theta. Open that bracket. Are you with me? U squared cos squared theta. So what's that the next thing? Sine over cos is tan. So we have our x to be equals to what now? Y over y equals to what now? S tan theta minus 1 times gs squared all over 2 times this. We have 2u squared cos squared. This is what we call equation of trajectory of a projectile. So I'm putting the link of the what now? Question and solution below this video. So watch that one too. Because we're going to solve question. I don't want this video to be too long. So we're going to solve what now? Question. I'll put the link down. Join our WhatsApp group. Like this video, subscribe to our YouTube channel, share the links to all your friends using JUPEB, JAMB, WAEC, A-level, and what have you. If you want to join us for physical coaching, if you want to join us for online lectures, online coaching, kindly click the WhatsApp link under this video. Till we meet next time, I remain your humble Shabala signing.